Welcome back to Bite-Sized Breakthroughs, where we dissect the latest and greatest in the world of artificial intelligence. Today, we're diving deep into the fascinating world of language model compression, specifically looking at a new technique called SparseGPT. Joining us is Dr. Paige Turner, a leading researcher in the field, and Professor Wid Spectrum, a renowned expert on the broader landscape of artificial intelligence. Paige, thank you for joining us. Let's start with the basics. What is SparseGPT all about?
Thanks for having me, Alex. SparseGPT is a novel one-shot method for pruning large language models, particularly those from the Generative Pre-trained Transformer (GPT) family. Essentially, it allows us to reduce the size of these models significantly without sacrificing much accuracy.
That sounds pretty impressive. We're talking about models with billions of parameters, right? Can you give us a sense of the scale we're dealing with here?
Absolutely. Think about the GPT-175B model, which has 175 billion parameters. That's a massive amount of information, taking up about 320 gigabytes of storage in half-precision format. To run inference on this model, you'd need at least 5 A100 GPUs with 80 gigabytes of memory each. That's a lot of computing power and resources.
So these models are undeniably powerful, but their sheer size presents a challenge for deployment. That's where SparseGPT comes in. Professor Spectrum, could you provide some historical context for this problem?
Sure, Alex. Model compression techniques, including pruning and quantization, have been around for a while. Pruning, in particular, involves removing parts of the network to make it smaller and faster. This has been successful for smaller-scale models and convolutional neural networks, but compressing massive language models like those in the GPT family has been much more challenging due to the sheer volume of information involved.
What's been the main roadblock to effectively pruning these giant language models?
Well, most traditional pruning methods rely on retraining the model after pruning, which is extremely expensive for these massive models. It requires huge amounts of computation and fine-tuning, rendering the process impractical. Also, prior post-training methods have mainly focused on quantization, which reduces the precision of the model's numerical representation, but they haven't been able to effectively compress models with billions of parameters.
So, SparseGPT is offering a new approach that avoids retraining and focuses on pruning. What are the key innovations of this method, Paige?
SparseGPT tackles this challenge by formulating the pruning problem as a set of large-scale sparse regression instances. It then efficiently solves these instances using a novel approximate sparse regression solver, allowing for accurate one-shot pruning without retraining.
One-shot pruning? That's a huge advantage over existing methods that require retraining. Could you break down the methodology a bit more for our listeners?
Sure, SparseGPT works in a layer-wise manner. It iteratively prunes weights based on a sequence of Hessian inverses, which are calculated efficiently using Gaussian elimination. For each column of the weight matrix, it prunes weights in a greedy fashion, prioritizing those with the highest magnitude. But SparseGPT goes beyond simply removing weights. It also incorporates an adaptive mask selection mechanism that dynamically chooses which weights to prune, taking into account the influence of previous weight updates. This adaptive selection process contributes to more accurate sparsity distribution and allows for non-uniform sparsity patterns.
It sounds like SparseGPT is pretty clever. How does it compare to existing methods like magnitude pruning and eta prune, Professor Spectrum?
SparseGPT stands out in several ways. First, it addresses the limitations of prior pruning techniques that become computationally expensive when applied to massive models. Unlike existing methods that require extensive retraining to recover accuracy, SparseGPT offers a one-shot solution, making it significantly more efficient for GPT-scale models. Additionally, SparseGPT outperforms existing accurate one-shot pruning methods like eta prune in terms of accuracy, particularly for larger models. Compared to magnitude pruning, a common baseline, SparseGPT can achieve much higher sparsity, up to 60%, compared to 10 to 30% for magnitude pruning at comparable accuracy levels. This highlights SparseGPT's ability to effectively handle the unique challenge posed by the complex architecture and massive scale of modern GPT family models.
So let's dive into the experimental results. What kind of impact did SparseGPT have on the models you tested, Paige?
The results were quite impressive. SparseGPT achieved remarkable results, demonstrating that massive GPT family models can be effectively pruned to high sparsity without retraining, resulting in minimal accuracy loss. Specifically, the largest open source models, OPT 175B and Bloom 176B, reached 50 to 60% sparsity with negligible perplexity increase, effectively removing over 100 billion weights. Larger models showed greater compressibility, exhibiting minimal accuracy degradation even at high sparsity levels.
That's fascinating. So bigger models are actually easier to compress. Why is that?
It's thought that this phenomenon is likely due to over-parameterization in massive GPT models. These models often have many more parameters than necessary, and removing redundant parameters does not significantly impact performance.
That makes sense. Professor Spectrum, what are your thoughts on these findings? What does it mean for the future of deploying these large models?
This is a significant development, Alex. It offers a practical and efficient way to compress large language models, enabling the development of more computationally efficient and memory-efficient LLM applications. This will accelerate the development and deployment of LLMs, particularly on resource-constrained devices and platforms.
And what about potential applications of this technology, Paige? How can SparseGPT benefit different domains?
SparseGPT has potential across various domains. It can be used to develop efficient and scalable LLM applications for resource-constrained devices like mobile phones and embedded systems. We can also deploy LLMs in cloud environments with limited memory and computational resources. Furthermore, SparseGPT can help build more efficient and responsive chatbots and conversational AI systems, and create new language-based applications and services that leverage the power of LLMs but are more efficient and scalable.
Those are exciting possibilities. It seems like SparseGPT is opening up new avenues for how we can use these powerful language models. But Paige, are there any limitations to this approach that we should be aware of?
Absolutely, Alex. The current research primarily focuses on unstructured sparsity and 2-4 semi-structured sparsity. Investigating the performance of SparseGPT with other sparsity patterns, such as block sparsity, could offer additional benefits for model compression. Additionally, while SparseGPT demonstrates impressive results, further research is needed to explore the potential of combining SparseGPT with other model compression techniques, such as activation quantization, to achieve even greater compression efficiency and accuracy gains.
That's a good point, Paige. Professor Spectrum, any thoughts on the next steps for this research?
I agree, Alex. There are several promising areas for future research. We need to fully quantify the performance improvements achieved through SparseGPT in various practical settings, considering factors such as latency, throughput, and resource utilization. We also need to explore how SparseGPT can be applied to other types of deep learning models, such as convolutional neural networks, CNNs, and recurrent neural networks, RNNs, to assess its generalizability and potential for broader impact.
It's exciting to think about where this research might lead. Paige, thank you for explaining SparseGPT so clearly. And Professor Spectrum, thank you for providing your expertise on the broader context of this breakthrough. Listeners, remember, this is just a glimpse into the ever-evolving world of artificial intelligence. Stay tuned for more bite-sized breakthroughs. Until next time.